This week we're going to look at systems of linear inequalities. So just like last week, we're going to be graphing lines and shading regions. We're just going to be doing two on the same graph at a time. So with this one, we have y is greater than x minus 2. So since this is a greater than sign with no equal sign, this one will be dashed. So in blue, I'm going to graph the line x minus 2. So I go to negative 2. It's a slope of 1. And this is a dashed line, so I'll draw that and erase like I have been doing. Okay, so that's the inequality y is greater than x minus 2. And what I'm going to do is shade already. So that's a dashed line shaded above. So I will shade this region above it. Then we'll talk about the other shading when we get done. So that would be the first equation, or inequality graphed. So for the second one, y is less than or equal to negative x plus 1. This is a solid line, and it will be shaded below. So I'll graph the line. I'm going to go to 1. Put a point there, and then the slope is negative 1. So it'll go perpendicular to this other one. Okay, probably don't need all those points. I just like to make sure I have them. Draw a line, straightens out, and place it somewhere there. All right, so this one says that it is less than or equal to. So we're going to shade below this line. And notice that I'm going to be shading on top of the green area. So the red line is what I'm shading below. So I will shade all of this area here. Okay, so once I do that, then the region that is overlapping, so the overlapping shaded region, that would be the solution region. So any point inside of that region would satisfy both inequalities. So what I'm going to do, just to make sure that's clear, is delete all of the excess shading. If I were doing this by hand, I'd probably just draw an arrow to the part where it crosses over, but okay. So there we go. That's roughly shaded. So the green, the darker green color there is the solution region. So if I were to choose a point in this region, so let's say I just choose, it really never matters because it's just a point in that region. So that's the point negative 5, 1. So if I plug this into both inequalities, I will get a true statement, hopefully. So if y is 1, x 1 is greater than 5 minus 2, and that's, that's negative 5. And so 1 is greater than negative 7, so that's good. And then in the second inequality, I would plug in the same numbers. So I have 1 is less than or equal to, that's a negative 5. That's because the x is negative there, plus 1. So I get 1 is less than or equal to 5 plus 1, or 6, which is also true. So that's a test point to make sure that that is the correctly shaded region. So this will get repetitive because these are all pretty much same thing. We're just going to graph the lines, shade the regions, look at where they intersect, and that's the solution region. So 2x plus 3, I'm going to go to 3, apply a slope of 2. Okay, draw my line. And this is less than, and it does not have an equal sign, so I'm going to delete portions to make it dashed. And then the next line, negative x plus 4. So go to 4. It's a slope of negative 1. So I'm just going to draw a couple points here so I don't get too crazy doing that. And that's pretty good. And so for the blue line, it says y is less than 2x plus 3, so we will shade the region below. So below 2x plus 3 is all of this area. And then for y is greater than or equal to negative x plus 4, I'm going to shade the region above the red line. So the region above the red line is up here. It's all this region, and you can see where the overlap is. And so that overlapped region is our solution set. And I'll just delete some of this because just to show you clearly where the solution set is. I'm going to have some color go over that line. That's all right. So that overlapped region would be the solution region for that system of inequalities. Okay, next one. So again, this is they're pretty much all the same. So the blue line, we're going to go to 2 and apply that slope of negative 1. And so on, draw a line. And so this isn't really much different than last week, except it's basically just 2 problems in one. That's a solid line. And then the red line is going to be less than, and it's negative x minus 2. So it has an intercept of negative 2. And remember I said that the solution region is where those things intersect, where the shaded regions intersect anyway. Okay, so that's good enough for that one. And then let's shade. So for the blue line, it says shade above the blue line. So I'll do that. Okay, next line it says y is less than, so we're going to shade below the red line. Okay, so like I said, the overlapping region is the solution region, but you can see here that these regions don't overlap. So this is where we don't have a solution region. So parallel lines, which are shaded like this, won't have solutions. So this is a no solution. So it's no solution because there's no intersecting region. So that happens sometimes. Okay, so to make it slightly more difficult, we have a story problem. Couldn't think of the word. Malia has $500 to purchase water bottles and pairs of socks for a fundraiser for her school's cross-country team. She needs to buy a total of at least 200 items without buying too many of just one item. What graph shows the possible numbers of water bottles and pairs of socks that Malia should buy? So we have this picture that tells us the cost of these things. So the water bottle is $2 and the socks are $3. She has $500 to spend. So with inequalities or equations, what we do, one of these is going to have to do with the number of items, and one of them is going to have to do with the dollar amounts related to those items. So I'm going to start with the dollar amounts. I know that this person has $500 to spend, and they will buy $3 pairs of socks. So I'm going to say that X represents socks. And let's have Y represent water bottle. And so we'd have 3x plus 2y. And she has $500, so she can't spend more money than she has. So whatever $3, $3 pairs of socks and $2 water bottles come out to has to be less than or equal to 500. And that's the key part, is to recognize that symbol. Okay, so that is the dollar equation, because that's $3, $2, and $500. So the next part said she needs to buy a total of at least 200 items, and we're going to focus in on this at least. So she needs to buy a number of socks and a number of water bottles, and needs to be at least 200. So that means that x plus y, however many things she buys, has to be greater than or equal to 200. So if you see this at least, this means it's going to be greater than or equal to. So you have to include the equal to. And then we just graph this. So this is going to have to be rearranged. So if we have, let's move this out of the way so I can do those separately. Let's work with the blue equation first. And we have to solve this for y. So let's subtract 3x. And so we have 2y is less than or equal to negative 3x plus 500 divided by 2. So y is less than or equal to negative 3 halves x plus 250. Okay, so I'm going to box that one. And then I'm switching colors with these, but that's all right. Let's solve the x plus y is greater than or equal to 200. That one's easy though. We just subtract x. So we're going to have y is greater than or equal to negative x plus 200. So those are the two equations I have to graph. So, the scale's off, right? So each of these blocks is worth 1. So we need to change the scale. I will make every 2 worth 50. And sometimes when I do this, I am wrong. It's hard to see sometimes. Okay. Like in this case, it's going to be really hard to see. Let me see if I can adjust that a little bit. Let's just do the same thing on this axis. Okay, so it has, let's start with the blue one. It says negative x plus 200. So there's going to be an intercept at 200 and a slope of negative 1. So since the scale matches, I can do this. So if I go down 50 over 50, that's a slope of negative 1. So I can have a slope that looks just like that. And I will connect that, or those dots. Okay, so that's the blue line. It's solid, and we're going to shade above. And then the red line is negative 3 halves x plus 250. So that one goes through 250, and we're going to go down 3 over 2. And so since, let's see if I go down 1, 2, 3 over 2. Let's make sure that's a slope of 3. So that would be 150 divided by 50. Yeah, that's slope of 3. And then we are going to follow that pattern. Okay, and I'm going to actually zoom in here. Because these lines are going to have, it's going to be a little bit confusing when I shade. Let's draw that line. Okay, let's call that good. And that is a solid line as well. So they're both equal to. So we have two solid lines. Now we're going to shade. So let's start with the blue one. I'm going to shade above the blue line. So that's going to be all of this region. And again, we don't really care about all of this region. We just care about where those two regions intersect. And for the red line, we're shading below. So everything below the red line is actually all of this stuff. But you can see how it started to adjust for shapes. That's fine. I know the colors are changing here, so ignore the darker pinkish color. But you can see here, it is really this region right here that is the intersection region. So it's that little space there. Let me delete a lot of this so that we can clean that up. So it's going to be, so just because the graphs are very close to each other, the intersection region is small. So I know I deleted numbers and all that, but the region right here, that would be considered the intersection region. And so that's the solution region.